Hello. I am Saitaro Kaneko of the University of Electrocommunications. I would like to present a preliminary study of pressure distribution measurement method by skin color change. The purpose of this research is to estimate the pressure distribution of the fingertip from the skin color change. In other words, we aim to estimate the force as shown in the heat map image on the right, using the video on the left that a finger pressed against a convex-shaped A. Measurement of pressure distribution to the fingertip is one of the sensing technologies required for high-quality tactile displays. The sensor array is capable of measuring the force applied, but it hinders the fingers from touching the texture directly. In addition, optical measurements can measure the displacement of the skin surface with high spatial resolution, but estimating pressure from displacement is difficult due to the complexity of the mechanical properties of the fingertips. In summary, it is difficult to measure the pressure distribution without contacting the sensor. In order to solve these problems, we propose a method that uses the skin color change under pressure. This makes it possible to measure directly on a texture, and even on very fine textures with a single camera. In order to realize this method, we first need to clarify the relationship between pressure and color change. In this presentation, we performed an experiment on this point. We have conducted 3 experiments in order to clarify the relationship between pressure and color change. In this presentation, we present an overview of Experiment 1 and details of Experiment 2. In Experiment 1, skin color change and pressure were measured when a finger was pressed against the uneven surface at a 2 mm pitch, using a color change measurement device and a load cell array, respectively. The results showed that the area under pressure and the color change area were roughly the same. This result suggests that the color change is caused by pressure. We also found that the skin color change was extensive. Therefore, we measured the color change in Experiment 2. In Experiment 2, we investigated the spread of skin color changes using a 2 mm by 2 mm linear convexity sample. 8 subjects participated in an experiment using the index finger of the dominant hand. During the measurement, the sample is submerged in silicon oil so that the convex part becomes optically transparent. The fingertips were photographed with one side of the binocular microscope in a magnified fingertip position. As a procedure of the experiment, the subject firstly pressed the fingertip against the texture in the oil. The subject adjusted the pressure so that the fingertips did not touch the flat surface outside the convex part. The subject held it pressed down for 5 seconds and released his or her finger, and repeated 3 times. Here is an example of actual measurement results. The red line shows the physical convex. From this, it can be observed that the color change extends beyond the convex. In order to estimate the actual color spread, the analysis was performed according to the following method. First, we extracted one frame of the image at each push, and then we extracted the green channel components from it. After that, the center of the convex part was used as the origin, and the luminance change was extracted as shown in the red line in the lower right-hand side of the figure. As a result, 24 data were collected. This is the result of the analysis. The horizontal axis shows the distance from the center of the convexity as the origin, and the vertical axis shows the luminance value of the green channel. The gray line in the graph is the data extracted from each pressing, and the black line is the average value. This shows that the color change is wider than the 1 mm area of contact with the convex part. We also observed a decrease in brightness from about 2 mm. In summary, the color change was found to extend 1 mm from the edge of the contacting convex. As a result, we found that the color change area is larger than the contact area. However, in this experiment, we measured only when the fingertip was pressed 2 mm, and we did not measure the actual pressing force. In the future, it will be necessary to clarify the relationship between the pressing force and the color change region. In addition, we observed that the color change was larger in the fingertip area than in the terminal direction. We think that the internal stress distribution based on the mechanical properties of the fingertip may be related to the color change, considering that the fingertip tip is close to the skin and bone and has thin fat based on anatomical findings. In the future, it will be necessary to compare the results of stress simulations using the finite element method for this investigation. Here's the summary. Thank you very much for your attention.